Okay, let us start from where we left in the previous class. I think in the previous class, did anyone see the recording on Blackboard? The mic was not on. So you will see everything but without any voice.
It's on now.
It is on now because by default on Teams it is on. On Blackboard by default it is off. You have to turn it on.
The recordings are published on the Blackboard?
No, because last time Teams was not available, so I used Blackboard only for one class. Otherwise, they are published on Teams. Start from where we left in the previous class with a little correction. The correction is basically the difference between. I'll make the correction, then I'll switch to the other page for week 2. This is the model we are working with. Correct? In which this is the equation of the line, and the whole thing is the equation of the point. I call it, or let's say actual line. This is one that we're after. We don't know this line. And this one is the equation of the point. Right? Now, we don't know the original line, but we do know some of the points. Not all of the points, some of the points. The one we picked in the sample, we know those points, we know them. So what we are going to do here, the correction here is that this is the sample that we picked, you see. We are not after the line that passes through these points. We are after the line, the actual line. So imagine that actual line somewhere here. The red line. This line is basically beta naught plus beta 1 xi. This is the actual line we are after. So the thing we need to minimize is the difference between the points and this line. No.
This line also minimizes the difference in this.
What we said here is EIs. We need to minimize epsilon i's. The difference between the points and the actual line, not the line that is going to come from the sample, the actual line, imaginary line, which we don't know. So this is the quantity we are going to minimize, epsilon everywhere. This is the quantity. We call it sum of squares of errors. Now to estimate these and getting to the formulas of beta naught hat and beta 1 hat, the objective is this. Not something significant, but conceptual. Something conceptual. You have to minimize summation epsilon I square and not the EI squares. Now I'll take you to the new sheet where I'll start week number 2. This is chapter 1 and some chapter 2. Now, let us restart with the model. This is the model, the equation of the point. Now, if you say here that I equals 1, 2, all the way up to infinity, you are referring to the population, of course. And if you say I equals 1, 2, all the way up to small n, you're referring to the sample, right? Where infinity is an indication whether the population size is known or unknown or too big or whatever. Infinity means something very large. You need to estimate a line. Which line? A population regression line. The line is this line. The population regression line. What did I write on the left side? Expected value, which means it's the mean of y for each x. You remember, when I made the line, let me go back to the diagram. When I made the line, what did I assume? I assume that the red line is passing through, where is it? The means of each distribution, means of each subpopulation. So at any point, the line will be equal to expected value of y for a given x, for any x. It can be x1, x2, x3, all the way up to xn. So this is what we are interested. We join those points and we'll get the line as a result. The problem we are dealing with is what? We need to estimate the two quantities, beta naught and beta 1 in the above equation. True? To solve this problem, we have formulated the following objective function. Minimize a summation of epsilon I square with respect to beta naught and beta 1. This is the objective function. You need to minimize this function such that the function is minimized. You need to get to those values of beta naught and beta 1 that minimize this function. So how do we minimize? A simple first derivative rule will be helpful here. To minimize, you just write the function, differentiate the function, and put it equal to 0, right? So the function is what? Summation epsilon I square is what? For this, I need epsilon, and I'll get epsilon from this equation. First equation, what will be epsilon? From here, epsilon I will be yi minus beta naught minus beta 1 xi. I put it here. It will be summation of yi minus beta naught minus beta 1 xi whole square. This is my objective function, and I need to minimize this function. To minimize this function, what I'm going to do is I'm going to differentiate first with respect to beta naught, put it equal to 0, I'll get one equation. Then I'll differentiate with respect to beta 1, put it equal to 0, I'll get another equation. I will solve the two equations and I will get the solutions. But before I do that, I want you to go back to some preliminary knowledge of summations and derivatives. What is summation of xi? Actually, it's what? x1 plus x2 plus all the way up to xn. All of us are aware of this thing. True? True. Very nice. What is summation of 2? It's basically 2 plus 2 plus all the way up to how many times? N times 2. What if I replace this 2 by any constant, general constant a? It will be 2n times a. Very nice. So when the summation is applied on a constant, you get n times that constant. Where is this small n coming from? It's the number of times summation is applied. Clear? Clear? What is summation of AXI? AX1 plus AX2 plus AX3 plus AX4. Here there will be no n. Why? Because there is a variable part in the summation. X is there. It's not completely constant. So it will be a times summation of xi. What does that mean? That means I can take a constant out of the summation if it is multiplied to the variable. True? What is summation of xi plus a? Summation has a distributive property. You can apply it if there is addition. So apply it separately. It will be summation xi plus na. It will be applied separately on xi and a. When it's applied on xi, simple summation. When applied on a, it will be na. This is one part, dealing with the summations. The second part is I think this is it. If I need it, I will use that. Let us start. Differentiate with respect to beta naught and put it equal to 0. The first task. That means I will differentiate with respect to beta naught summation of epsilon I square. And I will put it equal to 0. I will get one equation. Let us do that. This will be derivative of summation yi minus beta naught minus beta 1 xi whole square. Yes? Yes. Yes. Now I need something here. Some background knowledge. I think it's easy. I can explain it. What is the derivative of x square? 2x. Now what I'm going to do is I'm going to take the derivative inside the summation. I will show you how I do that. Okay, I will show you later how I did that and how it is possible. But for now, what I'm doing is I'm going to take this derivative inside the summation. And I will explain it one time. Next time when I use it for beta 1, I will not explain. Okay. So the first thing I'm going to do is I'm keeping it outside and I'm going to open the summation. It will be y1 minus beta naught minus beta 1 x1 whole square. First term of summation, I is 1. True? The second term of summation is y2 minus beta naught minus beta 1 x2 whole square. True? Plus all the way up to yn minus beta naught minus beta 1 xn whole square. This is epsilon 1 square plus epsilon 2 square plus epsilon 3 square all the way up to epsilon n square. Now apply the derivative separately. On each of these terms, apply the derivative with respect to beta naught. What will happen? There is a function of beta naught here, true? So a function of x, when you differentiate it, 2 times the function of x times the derivative of the function, true? So it will be 2 times y1 minus beta naught minus beta 1 x1 to the power 2 minus 1 times the derivative of the base. What is that? Minus 1. Only the first term. Plus the second term, exactly on the same pattern. Y2 minus beta naught minus beta 1 x2 to the power 2 minus 1 times minus 1 plus, I forget what, 2, yes, all the way up to 2 times, thank you, yn minus beta naught minus beta 1 xn to the power 2 minus 1 times minus 1. The minus 1 is the derivative of this thing. Like you have x plus 3 whole, let's say 2x plus 3 whole cube. If you want to differentiate this function, what will be the derivative? 3 multiplied by 2x plus 3 multiplied by 2. What is this 2?
The derivative of the
Base. Derivative of the base. Same, minus 1 is the derivative of this thing in the rectangle with respect to beta naught.
Okay, but in terms of the terms itself, which one of these are constant, which one of these are variable?
We'll talk about this. There is no summation at the moment. I opened the summation, so there is no discussion of constant variable at the moment. Everything is without any summation. Yeah, the power will be 2 here. Yes. Okay, now I'm going to put it back into the summation. I see the pattern again, so I will put it back into the summation. 2 times minus 1 is common in everything, true? 2 times minus 1. Now look at the remaining thing. What is the remaining thing? It's basically summation of yi minus beta naught minus beta 1 xi to the power 2 minus 1. Is it true?
Yes.
If you open the last summation, do you get the previous step back? Now you don't need to do all this. You do not need to do this whole thing. You can simply do what? You can simply take the derivative inside the summation right there at the top. And you will get the same thing. This one? The last one? Let me go step by step. I take 2 common and I take minus 1 common. What will be inside? Inside I will have y1 minus beta naught minus beta 1 x1 plus y2 minus beta naught minus beta 1 x2 plus all the way up to yn minus beta naught minus beta 1 xn. So whatever is in the square brackets, I wrote it in terms of a summation. The square bracket. Two is there, minus 1 is there.
Derivative you left it out for now?
Derivative is done. We already took the derivative here.
Oh, you got it inside there. Okay.
The derivative is already done. We differentiated. The power 2 became 1 because of the derivative. And we have to put it equal to what? 0. So when we put it equal to 0, I can divide both sides by -2. Yes? So when I divide both sides by -2, this will cancel. And I will have summation yi minus beta naught minus beta 1 xi equals 0. And now if I apply the summation inside, yi, is it a constant or a variable? Variable. Apply the summation the way you used to apply. Beta naught, is it a variable or a constant? Constant. N beta naught. Beta 1 times xi, is it a variable or a constant? Come again? Beta 1 times xi, a constant times variable is a variable, but the constant part can go outside. So beta 1 times summation xi. This is equal to 0. And by the way, the moment you put it equal to 0, the quantities become the estimated quantities. And this is called your first normal equation. Yes, x and y are the two variables. B0 and B1 are the constants. B0 and B1 are the slope and the intercept and the slope respectively of the red line. The red line, imaginary line, is the population regression line, and the line is of course constant, right? One equation we have, yes. Come again?
Assumption of this equation that equals to 0.
No, it's not the assumption, it's the objective. We want to minimize the sum of squares of errors, right? To minimize a function, you need to differentiate and plug it equal to 0. And to make sure that it is minimization, what would you do? Take another derivative. Take another derivative at this stage, what will you get? Before cancelling this -2 and all that, of course, you will not put it equal to 0. Take another derivative at this point. What will you get? You'll get what? -n. And n is what? Sample size. Can sample size be negative? No. So n is positive. -n will be what? No, not -n. No, there is a minus there. -1. It will be 2n plus 2n. A positive thing, which means the function is actually getting minimized. And because I'm not doing it here, that means it will come in exam. Okay? Let us do the second normal equation, which means we set summation epsilon I square differentiated with respect to beta 1 equals 0. When I do that, this will be a little complicated. When I do that, I will have summation yi minus beta naught minus beta 1 xi whole square equals 0. Again, without explanation, I'm going to take the derivative inside the summation. So I will have 2 as a constant. I can take that 2 anytime out of the summation or out of the derivative. The power 2 that is going to come down. 2 times summation of yi minus beta 1 minus beta 1 xi to the power 2 minus 1 times the derivative of the base. What is the derivative of the base? Minus xi this time. Look at this equation for a few seconds and try to digest it.
Oh, minus xi then.
Minus xi because I'm differentiating with respect to beta 1. So the derivative of the base with respect to beta 1 is minus xi. It is minus xi with beta 1. Let's do one more step in between. What I did is, first thing I did is, step by step, I took the derivative inside summation. Clear? Then what I did is, I took the derivative inside. 2 will come down. Yes? Derivative will be applied. Power 2 minus 1 multiplied by the derivative of the base. And then again, I took 2 as a constant. I took it outside the summation. Clear? Any confusion at this point? Yes. Look at it, the first step. In the previous derivation, we proved that summation and the differentials can be interchanged. Differentials can go inside the summation. Summation can go inside the differential unless there is a power attached. Here, there is no power at the summation. The power is inside the summation. Another important point. If the power is here, I cannot take the summation outside. Okay? You have to be very, very careful. If the power is over the summation, you cannot interchange. You can only interchange if there is no power at the summation. Now, there was no power at the summation. First thing I did is I interchanged summation and derivative, which I can do here. This came here, this came there. Clear? It's okay to do. Look here. In the first derivation here, look, the derivative is outside at the top. Summation is inside. True? When I did some steps, ultimately what happened at the bottom? The derivative went inside, summation came outside. It's justifiable, not a shortcut. After doing that, I just differentiated inside. Once the differential is inside, I just differentiated the thing inside. The derivative of something square is what? 2 times something to the power 2 minus 1 multiplied by the derivative of something. The base is that yi minus beta naught minus beta 1 x. So I differentiated this one. It became 2 times. Let me write it this way. Summation 2 times 2 came down. Yi minus beta naught the base to the power 2 minus 1 times the derivative of the base. What is the derivative of the base with respect to beta 1? Yi. Do you see beta 1 in yi? There is no beta 1 in yi. The derivative is 0 minus beta naught. Any beta 1 in beta naught? No, the derivative is 0 minus something times beta 1. What is the derivative of minus xi times beta 1? Minus xi. So minus xi is there. Now, can I divide both sides by minus 2xi and cancel the xi? No, I cannot. Xi is inside the summation. I cannot take it outside because there is a I in the subscript. Anything that has a I in the subscript, it depends upon summation, and you cannot take it outside the summation. This part, it has no I in the subscript. It's not changing with I. So it's a constant. You can take it out of the summation. So minus 2, I will cancel. Minus 2, minus 2. This minus, this minus, and this 2. They will cancel out, but not the xi. And then my second normal equation will be what? Apply the summation inside. It will be summation of yi. True? Yes. What? Times, yeah. Summation of xi times yi minus beta naught times summation of xi minus beta 1 times summation of xi square. This is equal to 0. Beta naught? No. Again, I will do this I will break it in 2 steps. First thing I'll do is I'll apply the summation inside. Okay. So what I do is a summation of, I'll break it into 3 steps. Summation of, let's multiply xi inside. It will be xi yi minus beta naught xi minus beta 1 xi square. This is equal to 0. Clear? What I did is I just multiplied this xi inside the bracket. Everything same. Clear? Then I apply summation all over. It will be summation of, it's there. It's there. Then apply the summation. We multiply it by n when it's a complete constant. Like 2. Like 2. Here again, I give you the reference. The summation of 2 is 2n, but the summation of 2x is 2 times summation of x. So this one is not a complete constant. This is called your second normal equation. So I have now 2 equations. And in those 2 equations, the moment I put it equal to 0, these become sets. So I got 2 equations. The first equation is the 2 equations are a summation of yi minus n beta naught minus beta 1 times summation of xi. This is equal to 0. And the second equation is summation of xi yi minus beta naught summation of xi minus beta 1 summation of xi square. This is equal to 0. These are the 2 equations I got. Solve the first equation for beta naught. What do you get? Divide everything by n. Divide the whole equation by n. What will you get? True? Divided throughout by n. What is summation y over n? The mean, y bar. What is summation x over n? X bar. So I take beta naught hat to the other side. So I will have beta naught hat equals y bar minus beta 1 hat times x bar. And you have seen this equation for the estimated intercept. Similarly, I solved the second equation for beta 1. What do I get? I get let me take beta 1 hat times first let me put the value of beta naught hat there. The one I got from the first equation, I will plug it in there. So I will have the second equation basically is summation xi yi minus beta naught hat times summation xi minus beta 1 hat times summation xi square. The first thing I'm going to do is I'm going to take this and put it in here. Okay, and this is equal to 0. When I put it in there, I get summation of xi yi minus y bar minus beta 1 hat times x bar times sum of xi minus beta 1 hat times sum of xi square. I get this. Then I multiply it all over. It will be summation xi yi minus y bar times summation xi minus beta 1 hat times x bar times summation xi minus, is there a minus or a plus? This is plus, true? Beta 1 hat times summation xi square, and this is equal to 0. Clear?
Simpler form.
Give us some time. Now take all the terms involving beta 1 hat to the other side. Negative will become positive, positive will become negative. So it will be beta 1 hat times summation xi square minus beta 1 hat times x bar times summation xi. This is equal to summation xi yi minus y bar times summation xi. Clear? Take beta 1 hat common from the left side. You have beta 1 hat summation of xi square minus, I will open x bar, it will be summation xi over n. Yes.
The right side should be
The right side.
the right side there. The sum of x bar minus y, the sum of
No, I took this one. No, I took this one to there.
Okay.
And this one, I took the right side to the other side. It has to be one negative. I changed side of this thing, not the other thing. The other thing is still there. You get it or no? You don't get it. I will tell you. I'll tell you what I did. I did this. Wait. I did this. Okay, now look at it. Take your time. Take your time. I took two terms to the right side. They became negative, yes. The two terms that I took to the other side are these two terms. Yes. Now, if A equals B, can I write B equals A? Yes. So I'll write the right side on the left side on the right side. This is what I did. And then I took beta 1 hat common. And then I took summation xi square minus x bar summation xi equals summation xi yi minus y bar summation xi. I just took flipped the sides. Clear? Now what I'm going to do is I'm going to write x bar and y bar. I'll open them. So I will have beta 1 hat equals summation xi square minus, it will be summation xi over n. True? And similarly, y bar will be summation yi over n.
One hat.
Clear? Now take this term and take it to the other side. The one that is multiplied by beta 1 hat, it will be divided on the other side, and your beta 1 hat will be summation of xi yi minus summation xi summation yi over n whole divided by summation of xi square minus summation xi whole square over n. Have you seen this thing before? We have seen this thing before. The only difference is you called this thing before as sxy and you call this thing as sxx.
Now we have to prove. Now we have yani.
So this is the
Solving.
proof.
We have proved it. We don't have to. We have proved
No, I
it.
mean in the exam.
Yes. We have proved it. Now it has many similarities with many things. Why do I call this thing as sxx? Because it has many similarities with the standard deviation of x. It's not exactly the standard deviation of x. If it was standard deviation of x, I would have called it sx. Simply, I'm not calling it sx. This is similar to the standard deviation and not exactly the standard deviation. How? Your standard deviation of x is what? Is this true? True?
Yes.
Try to open the square. Open the square. A minus b whole square is what? True? Then apply the summation inside. True? Then rearrange this thing. This thing. Minus, I'll write the definition of x bar. X bar is what? 2 times summation xi over n, and there is another summation xi, plus n times summation xi over n, and there is another summation xi over n. True?
Yes.
Now you see this one cancels with this one, and you have summation xi square minus 2 times summation xi whole square over n plus 1 times summation xi whole square over n. Is it true? Whole divided by n minus 1. True? And if you simplify this one, it is summation xi square. What is this? Same terms. Plus 1 times minus 2 times. What will you get? This is variance of x. Is it true? Without square root, it's the variance. With square root, it will be standard deviation. Is it?
Yes.
What is the numerator of the variance? It is the same that we are calling sxx. So your variance is basically ssx divided by a constant, which is sometimes n minus 1, depending upon which variance formula you are using. So it's not exactly the variance, but it's basically the numerator of the variance. And similarly, this is the numerator of covariance. we stop at this point and we will continue, or maybe we do this derivation one more time in the next class. If you have any questions, you can ask. If you don't have a question, you can go.
Do we have to prove this later?
Of course, I'm not doing it for fun. Other than the proof, you have done everything in the previous course. So the contribution of the course is proof.
Can you just go up again, please? You mentioned something regarding the derivative of this.
Stop me. Wherever you want, stop me, okay?
Actually, I'm not sure where is this. You mentioned something that the derivative of this equation is 2n or something.
2n?
Yes.
Yes. Come here, I will tell you. The objective, look. The objective, it's not moving. Look here. The objective is to. The objective is to minimize, right? When is it? When are you sure that the function is getting minimized? How do you check if the function is minimized or maximized? The first derivative rule does what? It optimizes the function.
Okay.
By optimize, we mean either minimize or maximize.
Okay. I should take another derivative.
Take another derivative to make sure it is minimized. If the second derivative is positive, the function is minimized.
Yes. Okay.
Now, the first derivative is somewhere. Where is it? It's here. It's here. Before putting it equal to 0, the first derivative is here.
Okay.
With -1, with 2,
Okay.
without cancelling anything.
This is the first derivative.
Yeah, that's the first derivative.
Okay.
Without cancelling -2 and -1.
Okay.
Then take another derivative of this one. Without any cancellations, take another derivative.
Okay.
Another derivative will be, the derivative will go inside the 2,
Okay.
inside the summation.
Okay.
Derivative for yi will be 0. Because you are differentiating with respect to beta naught.
Ah, okay.
The derivative
so you're assuming that the only variable here is
beta naught.
Okay.
This will be 0.
Okay. This will
The
be minus
derivative,
1.
this will be -1.
And this will be
This
0.
will be 0.
Okay.
And this will be -1.
Okay.
So -1, -1,
Positive one.
+1, and then summation. You apply the summation on a constant.
Okay.
It will be
Same.
n times 1.
Okay.
So there will be 2 here also. So n times 1 times 2.
N times 1 times 2. Okay.
2 times n. Now this whole quantity, 2 times n, is it positive or negative?
Should be positive because
Should be positive
n
because n is
positive.
sample size.
Yes.
Sample size. So the whole thing became positive, which means the function is actually getting minimized.
Okay. Just trying to. Okay. I can left.
Give me a second and wait. You have a class now?
It's okay. It's okay. I can come.
The xi here, it's a variable or a fixed number?
Xi is a variable with respect to I. But if you are differentiating with respect to beta naught, then you will assume xi to be fixed. It depends upon what you are differentiating with respect to. Wait, I will explain. Wherever your confusion is, I will explain it to you. Number, do you remember your serial number?
Number 2.
Number 2. Bender?
Yeah. To me, it was,
Number 7. Saud?
yes.
No. Saud Fahad, yes. Where is one note? Here.
Okay. So here the other derivative is positive 1, right?
Yeah, I'll show you now. I take this equation. The equation is 2 times summation of yi minus beta naught hat minus beta 1 hat times xi times -1. This is the first derivative.
Okay. Another derivative.
Now I take -1 outside before taking. It becomes -2 summation of yi minus beta naught hat minus beta 1 hat times xi. Now I take another derivative. With respect to beta naught, it will be the second derivative now. I put squares. So it will be -2. Yes. Also summation and derivative will go inside the constant and summation, everything. What is the derivative of y with respect to beta naught?
It should be -1, right?
The derivative of y, only y with respect to beta, 0. Derivative of minus beta naught with respect to beta naught, -1. Derivative of something, 0, 0. -2 times summation of -1. True? What is the summation of a constant? N times that constant. So it will be -2n plus 2n. Minus minus will cancel. Now this is the second derivative.
So this one should be -n.
This one should be -n times -2. Yes.
Thank you so much.
Now because the end result is positive, the function is minimized. Yes, Mohsen.
We know about xi.
Xi, yes, it depends upon what you're differentiating with respect to. If I'm differentiating this whole thing with respect to, let's say, beta naught, then apart from this thing, everything else is constant. If I'm differentiating with respect to beta 1, apart from this thing, everything else is constant. Even xi is constant. Yi is constant. It depends what I'm differentiating with respect to.
Because you said yi and xi is a variable.
They are variable with respect to
Summation.
I. Yes, with respect to summation, they are variables. Yes, but look, summation of xi. This is what? X1 plus x2 all the way up to xn. True?
Yes.
If I differentiate this thing with respect to beta naught, differentiate this thing with respect to beta naught,
All of them is 0.
all of them are 0. Still variable, but constant with respect to what you are differentiating.
Thank you.
Doctor, sorry, a quick question.
Mhm.
Why here you're taking the differentiation in terms of or respect of P naught?
Because these are the two unknown quantities we are looking for, beta naught and beta 1. So first I differentiated with respect to beta naught, then I differentiated with respect to beta 1, then plug it equal to 0 to get the solutions for these two constants.
And then
Khalas, I will get the formulas for these two. I got them.